So for the first video I'm going to do today, I'm going to do it over scientific notation because even though it's something that's pretty simple and that most of you guys have already learned about in high school, it's really important because oftentimes in chemistry they don't write out the full number because it's so big, and scientific notation is used a lot, so it's important that you know the rules and how to apply it to your problems. So first we're going to go over the rules of scientific notation. And rule number 1 is that all numbers must be between 1 and less than 10. So you can't have something with double digits. You need to put in, like, you wouldn't have something like 11 times 10 to the second. Instead, you would have 1.1 times 10 to the third. And for rule number 2, that would be that all exponents on the 10 must be whole numbers. So you wouldn't see something like 1.1 times 10 to the 23.5. It needs to be a whole number there. And rule number 3 is that the exponent on the 10 is equal to the number of places you move the decimal to satisfy rule number 1. So how you would figure out what number you put on the exponent for the 10 would be, like, for example, if you had 1,250 and your number can't be greater than 10, so your decimal would be right here, and then you move it 1, 2, 3. So that would give you 1.250 times 10 to the 3. And you can also use negative exponents because sometimes it's a really big number, but it's in this direction. So how you would do this is that you know the decimal needs to be here, and to get it there, you had to go 1, 2, 3, 4 in the negative direction. So it would be 4.50 times 10 to the negative 4. And for rule number 4, it states that if the original number is between 1 and 0, the exponent will be negative. Otherwise, it is positive. So that's what I just showed you above here in representing this, because it is less than 1 and it's greater than 0. And for rule number 5, only have as many numbers as you have significant figures. Sorry, I didn't know I was off screen. Significant figures. And sig figs are something that's also really important to learn, and I'm sure you guys will learn about in other videos. But this is when you follow the rules for significant figures, that's how you know how many numbers you will report your answer in. And there's rules such as all non-zero numbers are significant, zeros between non-zero numbers are significant, zeros that are leading are never significant, zeros that are trailing are only significant when there is a decimal present. And those rules will be accessed when you're looking at the numbers they give you in your problem so that you know how many significant figures in your answer to report. And so we're going to do an example, and so the number 8.72 times 10 to the negative 3, when taken out of scientific notation, would be, so you get the number 8.72, you know it's in the negative direction, so it wouldn't be going to the right. Instead, you would be going to the left, and that would be 1, 2, 3. 0.00872. So I know this seems pretty simple, but it's a pretty important topic to master, and I hope you guys can practice it in the modules and in the books. And let me know if you have any questions. Thank you.